welcome to this presentation about success without actually using requirements engineering, or with a little bit of it. A little bit about myself. I am Showayb Zahda and I work as a software engineer at Access Communications. My focus basically, or my degree is, I studied software engineering and my focus was on requirements engineering, and that's where Baldwin said that I changed. Because when I studied requirements engineering, it's important for me to actually have the requirements there and like have the requirements in the process and stress on requirements, because we believe that requirements are a key factor in success of any software development project or product. So then I was working at Access for the past 3 years and a half, and then I found we don't have requirements. Then I decided to run a master thesis project. I had two students studying the requirements engineering process at one department. It's a big department where I work actually, and then I'm presenting here the findings, mainly the findings of this study. So as for the agenda, I will start talking about Access Communications. Briefly, I will just go what is software project lifecycle in case someone doesn't know what that is. And then I will talk briefly about what requirements engineering lifecycle, agile software development, and lightweight requirements. So these are going to be the first 5 minutes, more of recapping for those who know them or don't know them. They will have an idea about the coming terminologies. Then I will focus about the requirements engineering process at Access Communication, which is the core topic of today. I will talk about the benefits and the drawbacks we are facing at Access, and if this process we are dealing with actually is scalable, can we still use it as we grow in number of people working? And then I will conclude my topic. If the time allows, Baldwin will talk about how testing and requirements work together. Okay, Access Communications, since we did a little statistics before and everyone more or less knows about it, so I will be briefly talking about it. We produce hardware and software in the camera surveillance world. So we are number one in the world that producing all these kinds of cameras and software related to them, their accessories. And lately we invaded the market of access control, so those devices you see on the doors. So we have a product that is now in America and Europe. And the rest are actually different kinds of cameras depending on the use case, indoor, outdoor, dome, PTZ, etc. So we have a big profile of cameras and encoders for those who are using analog cameras. Now, for these cameras, we have only one software. That's like the operating system, or what we call firmware, that is installed in all of them, and that is different from device to device based on the needs. So as I said earlier, we are the number one in the world related to this field, network videos. And we are actually, our headquarters is in Lund. We are about, according to the third quarter 2014, 1,867 people. 3 years ago when I started, we were 900, so we doubled, more or less. This is the total sales, 4.7 billion Swedish krona. And the company was founded as an IT company in 1984 by 3 founders. And we actually have a presence in terms of offices in about 40 countries, and this number is growing. And we have more or less all over the world partners working with us, developing software and integrating, selling, buying our products, etc. So this is a map just showing where we are in the world. So we are more or less covering the whole globe. So that was briefly about Access. I'm not going to promote the company here. I'm more interested in talking about what we do in this one. This is just one slide talking about the software project lifecycle. I'm not sure if any one of you, or I suppose many of you know this one. I will go quickly through it. So any software project, I'm not talking about a product, will start with requirements. And then from the requirements, the software designers, I think we have 1 or 2 here, they will make the architecture or the design. Then implementation starts with some developers. Then we send it to QA. Then we deploy. After this is successful, you send it to the market, to your client. and then a maintenance phase starts. So this is just going what we call waterfall model. In the waterfall model, they go strictly one by one, step by step, and if something goes wrong, they start over again. And so this is about generally how a software project lifecycle goes. Now, when it comes to, if I just take the requirements part of it, that's what is interesting. It looks like more or less this graph. I don't know how many of you have seen this, but it's quite popular. So I'm not sure if you can read it. Usually a customer comes to you and asking, like, I need this swinger. And then as a project leader, you understand that, okay, it looks like this one. Then you transfer it to the engineers. They will design it this way. It will be executed like this picture. And then the sales will make it like, oh, it looks that nice. Documentation, which is what we are going to talk about, is exactly as clear as this one, nothing. And the operation sales will install it in this way. The customer will be billed like, roller coaster. And then the help desk, well, they don't know much about what's going on. And actually the customer wanted this one. So this is how it goes. And the problem is here, actually the customer explained this one, but he wanted this one. As you can see, all of these steps, they have human involved in them. And that's where most of the problems come in requirements engineering. If we take away human, I think most of the problems will be solved. But that's unfortunately not the case. Okay, if I go deeply into the requirements engineering life cycle, it goes into 5 phases usually. Some people might argue differently, but we will take it that way. So it starts with analyzing the requirements. You get some requirements, we start analyzing them. From there we go into specification. So we put them in, let's hopefully human readable language. Some will put them in graphs, UML, etc. And then they go into validation. It depends on the process you use. You will validate what you specified here. Can I test it? Is this really going to work? Is this what we wanted? And then, sorry, we should start from elicitation. And you start with elicitation, asking like people for what they wanted, and then you start analyzing what they asked you for. Then you write the specification, and then you validate against this step. And if you find something wrong, you have to go back to elicit it again and ask people like, was it this way or that way? The core here, all of them, they need management. Requirements need to be managed, especially we are dealing with normally human language, and then some graphs that have to be interpreted in certain way. So management is a core problem actually. Maybe the other 4 elements are not there. Why is that so? Because after this is finished and we move to the next phase of the, let's say, implementation, then we need, how was that before? Then we have to go back to some documents, and if we don't keep any document or we don't manage any information, we don't hold it somewhere, then we have a problem. Or that's what the traditional case says. So some of the problems, as I said earlier, is that requirements engineering is a human-intensive activity. So many humans are involved, different opinions, different stakeholders. Everyone is thinking from their own dimension. So like the sales will think in different way than the product specialist, than the programmer, than the tester. And that's actually a bit of a problem. Then the requirements actually over time, they keep changing, especially if we have technologies that keep changing. Like in our case, the camera, we have sensors. We have new operating systems coming, or you have new technologies appearing. The trends change. So some requirements will go through many changes. And that's actually a key problem. Incompleteness, as I said, a human, well, I wanted the camera to record. Okay, record for how long, how, etc. So it's incomplete requirement, or someone is asking you something that is not really complete. So you have to actually make it complete in order to implement it. And it's ambiguous because it's sometimes they are using some word and it means something, and they actually meant something else. So you have here human interpretation. And another important factor, especially in our field, that the requirements keep growing in number. As we keep developing products, new technologies are coming in, we're adding in new features, so that means the requirements are growing. And that growth needs to be managed somehow. And this all of them are actually affecting the budget and the time, and we have these are limited because you have to be early in the market to sell your product, because at the end of the day you need the cash. So these problems are all common problems in requirements engineering, and these are just examples, so the list actually goes on and on. So some of you worked with Agile, I think it was you, so this will not be new for you. So I'm going to talk about Agile software development briefly, what it is. As I mentioned second slide about the software product life cycle, it is a waterfall model. That means we go from one phase to another. When Agile came, Agile was like, no, we don't want to work that way. We work in small iterations in which actually we go through all of these things, but we scope down what we are going to do. So a scope, that's what they call an iteration. And continuous integration, they mean here, okay, we take this iteration, we develop something small, and then we deliver it. And then the next iteration, we deliver the next thing. And that way, the implementation or your product is growing, and you are having something real that you can see as, let's say, prototype. Another principle is called test-driven development, in which you actually write tests before you implement things. I have to say that doesn't work with everyone. It's not easy for developers. Being a developer, it's not sometimes clear to do it, but I have done it many times and it seems to be useful. So code ownership is another principle that when you work with Agile, that who owns the code? Can I touch this code? Can I not touch this code? If I touch it, what will happen? Something like that. So this is another principle that if you enable the developer to own their code and do it the way they like, they can produce better code. Scrum is another thing that falls under the umbrella of Agile software development, which is more of how to manage the iterations. And here, another key factor is less documentation. Agile focuses on less documentation. It focuses more on clear code, clean code. Since you work in small iterations, okay, we don't maybe need to document everything because in 2 or 3 weeks we are coming back and we will discuss that. So that's another key factor in this one. So these are actually few points about Agile. I'm not going through the whole list. But Agile came as a result of the difficulties that people are facing when they specify the requirements in general in projects or a product, mainly software. I'm not sure about other fields. I am interested only in software projects. So that's why they came up with Agile. If Agile is working, this is actually a matter of research. Some companies it works for them, some it does not. How many of you here is using Agile and it works for them? So we have 4 out of 20 people about. So, okay, there is another term called lightweight process. That means, lightweight is sort of self-explanatory word, and the process is so we talk here in this process about continuous prioritization and prototyping. As we talked earlier, we have iterations, and now we make, okay, we have this iteration, let's make a small prototype, test it, is it working? Yes, we learn from it actually, and then we can build upon it. So here we don't focus on going through the process step by step. So we take things in small iterations so we can manage them. So it's more about being able to manage things. We can elaborate things in time, as I said earlier. If we make a mistake now, okay, in 2 weeks we can actually know about it. It's different when you do it in waterfall model, that you have, maybe you are at the end of the year and you have to go and work everything. At least it is easier to manage mistakes. And it is iterative development, as I mentioned earlier. And documentation is rare. And that's a key point again. So we don't focus on documentation. But this is the question, does that really work for especially large companies? In a small company, it could work, but on large one, it's not necessarily the case. So the topic that I'm going to talk about is how we at Access Communications run without requirements, or with actually a lightweight process with requirements engineering. Before I start talking about the topic, it's good to actually introduce the teams. How many are we? How we are divided. So this is more about the team. So we have actually product management team that deal with the products we have. We have a big portfolio of products, maybe 300 products. So there is a whole department that takes care of the products and how they should look like, and the target customers, etc. And then we have development teams. So we get from the product management like, hey, we want this feature. So it comes to the development teams, and development teams are divided into functional teams. So bare specialization. So each team is specialized in doing something, and then they own everything in that part. So that's when I talked about code ownership. Then we have quality assurance department, like Baldwin. So whatever we develop, we send to them. We deal with them actually as a third party, although we work in the same company. So we make sure that if there is a bug, they will really report it to us. Because if we as developers test our code, we might be biased. Like, no, it shouldn't be that way. No, it should be that way. But when QA or quality assurance, they say it is a bug, then we have to really look at it. So that's another department. Okay, in the firmware platform department where I work, we are about 200 people with another department that deals with the product, working on the whole firmware platform. And we are divided into teams, as I said earlier, functional teams. Each team consists of about plus minus 8 people. This magical number, I suppose many companies have that number in their teams. So this is roughly about how we are organized. Now, what about the process we have? So, as I said earlier, this was a master thesis study. So we only studied one department, which is the Linux firmware platform. And this department has sub-departments in it. So it was everything related to that department and how the department is actually managing the requirements in relation to the software. Since we produce the platform of the whole system, we should actually know about how it functions. The good news is we don't have any actual development process. We just work as we like. So it's about some freedom. Each team chooses what suits them best. Like some is using Scrum, some is using Agile, some is using Kanban, I don't know. There are different terms, everyone is trying different way. But the good thing is everyone is delivering on time, and they are doing good job. So here we have actually something we can learn, that maybe not having a process is something good, but that has to be supported somehow by some way, and we will learn later what that is. And the other good news, we don't have this. No requirement database, no requirement repository. So if someone wants to know how this works, yeah, you don't really find it in documentation. Maybe you can go and try it on the product yourself, or you have to go and talk with someone who works with it, like how exactly it should work. But to find a complete description, it's unlikely. Requirements are only documented actually during the projects. So we do have requirements, but we don't keep them. They die when the project is finished. So each project has, let's say, a website, and we keep everything there. But to go back to this project after 2 or 3 years to know how things work, etc., it's not easy to find. So you find documentation, and if you actually find them, they might not be updated. That's another issue. So it's not necessarily that you can trust whatever you find with the information. So here in our process as well, we depend heavily on this. We have direct and informal communication. So if I need something from QA, I just walk to them, I go talk with them, we fix the problem, I go back to my work, they go back to their work. When a product specialist wants something, he comes to me or to another developer asking, testing. So we work closely together. So this actually helps a lot. And we usually, when we get orders, like an order here is like, we want this feature to be done or something like that. So a request for feature, let's say. We get it in high level. I am interested in, let's say, face detection application. Okay, that's what you get. And then you have later to go through many steps and discuss with people like, what should we do? How should we do it? What do they mean by face detection? Is it like anyone in the street, or maybe it's someone who's in front of the camera, like me now facing this camera, in that aspect. So the specifications are not there. You don't know. You just get an order, high level. a line or two. That's it. Yes.
You have development only in Lund, or is
Yeah.
it all over the world?
Yes, development actually is mainly done in Lund. We have a small department in China that is developing only for the Chinese market because they have their own laws. So that's the only place outside Sweden. The rest is in Lund.
So it's direct and informal communication. You can just walk into the same building.
Yes, we are not in one building, but we are located, let's say, in close enough. So it depends on the department. But we are, as departments, co-located. So all the firmware development, Linux, we are in one building. QA, for instance, they are in the neighboring building. So we can walk to there. Maybe marketing, they are in the next building on the opposite street, but we don't interact with them that much. So it depends. So the location of each actually department is important, and then they keep shuffling us. So we are co-located next to each other. We also work on this one, which is actually driven from maybe Agile. We have demos frequently, like each iteration now we have a demo. We show it to the product development or the product owner. They can see, feel what they wanted. Is this what I wanted? Oh no, it was actually, that's right, I wanted that one, but now I changed my mind. So we can actually get information from early. We have also quality measurement and benchmarking. We use that as requirements. What do we mean here? Since we don't have requirements specified, so how do I know that when I release the next version of the firmware, I didn't degrade the performance? So the camera used to deliver 30 frames per second, now it's 20. So do we deal with that? How do we deal with that? So we use that as benchmarking. So we have certain actually quality requirements that we set, okay, we shouldn't degrade here. Maybe other things we can. So there are key factors or key features that we shouldn't degrade. So we make sure that these are sort of, they work as requirements. So actually to depict what I said, how the organization works together. So in this small here is the LFP. That's the, let's say, the operating system that we put in the camera. And we have different departments, as I said. So we have the product management here. And then let's say that this is the firmware development, and this is the new products development. So they keep ordering features from both. So here actually it says order products, so that's the new video development. And then they order from them, so they divide their job into projects and they start working. And then after they finish, they put their work in the operating system, in the LFP. At the same time, we have features that come for all the products. And then we develop it, and it goes to the same place. And then we have other departments that are actually working against this. Either they deal with our partners, we have quality assurance, we have marketing, different departments, support, etc. And here, as you can see, we have interdependency. So we somehow deal with each other. Although we are separated organization, but we still deal with each other. So,
Question.
yes.
If you have that kind of organization with a platform organization and product
Products and features.
But how do you know if the feature is generic or just product specific?
Well, we have sort of configuration management system. If a feature is going to be only for one product, then we configure that product to only fetch it for itself. But often we develop a feature for the whole system or for the whole, let's say, family of products. Like when we have a fixed camera, let's say, so it has certain features. So everything goes for that. So it's not one product per se. When we develop for a series of products. So we usually configure that. We have a management or a configuration management system to specify actually this goes only for that camera or for a series of cameras or for everything. So that goes actually more on the configuration management level. Did that answer your question? Yeah. So when new product
that means that you have a certain strategy to handle that.
Yes, we do. We deal with about 300 products, so we should have.
But I would like to chip in that a lot of the time we actually are not sure. And it's okay. I'll elaborate on that.
Actually, as a developer, we don't do it quick and dirty. It's a rule. It should go through certain design, unless we are just about on the deadline. Maybe we can put some dirty code there, but it should go through some process that we go through code review, design reviews, etc. So it takes some time actually to get the code clean and proper. Actually, sometimes we develop a demo in one day, but it takes us 6 months to do the real implementation with with testing, etc. So it depends on the feature and what we do. Here we, as a leading company in the world, I think it's important for us to stay robust. That means our camera doesn't crash. It should always operate. And that we deal with the security services and systems. So you cannot sell, for instance, an airport or a nuclear facility with a camera that is breaking every day and etc. So that's important for us to have a robust system. Okay, so the process, what I talked about, it goes like this. So we have a big business strategy, big managements putting it. They go into roadmap. This year we want to do these features. Then these will go into orders. So like each feature will go into a project by an order, and then there is a responsible person who will like decide this is how it should behave or not. And then the project will produce two types of documentation. So remember here I'm only talking about one phase of the project, which is the requirement, or I'm interested in the requirements only. So we have project-specific documentation and we have reference documentation. Each one means something. Project-specific documentation, these are documentation that only live during the course of the project. Otherwise they die. Or they are still there but no one cares about them. And reference documentation are those documentation that we keep actually in the platform with the code, let's say, or somehow they live with the platform as we progress. And these are some design documentation, API documentation, which is important. We have well-documented APIs because we deal with third parties. So if we don't explain ourselves right, they cannot develop software for us. So these are actually the two types of documentation that we keep. And they could work as requirements, at least the second one. Because we deal here with features when we deal with an API. And then when we have well-documented API, we know how it worked at least. So we use that as somehow sort of documentation. And testing can use it actually to test against it, like how did they describe it, how does it work. So that's mainly the sort of the only documentation that you can find actually in documents that actually is up to date. Okay, but how does it go, how does it work?
Take that picture again.
Yes.
But if I'm a tester, what kind of input document do you provide to the test department? Or is it a special test department or the tester is hosted in the project?
Actually, I'm coming to it soon. Should I delay the answer?
Okay.
Yes.
And I will go into even more detail if we have the time.
Okay, so a new employee comes in. How does that person get information or knowledge about what's going on? So you have colleagues, friendly, open, and that's where actually most of the requirements are coming, and that's helped by that we are actually open and we motivate going to the offices and talk to people. You have test cases and the source code. We have many test cases that maybe Baldwin will cover later in details. And they could work as source of requirements or knowledge. Like it states the steps of how to do something, but it doesn't necessarily say that this is how it should function. And you have good source code, but not everyone can read source code. So a product specialist cannot really read source code. So this could be useful for the programmers as way of documentation. So we have actually some documentations that I said about, like the API and some architectural design, some documentations here and there. You have the product itself, which is important. Since we have been in the market for the past 17 years making these products, so you can actually go to the previous product and test it. Oh, it worked that way, so now you know how it is. You can test, like more or less work like a tester and get the feeling how it works, and then you understand it. And you can combine all of them together to have a clearer picture of how it works. So these are mainly the sources of knowledge about how it works or how you get information. But to help for that to work, actually, you have to facilitate that somehow in the organization. How do we do that? We have actually a culture depending on the 3 core values. Let me step to them. The first one is called always open. So at Access, you should be always open. And that means if anyone steps into your room, you should really answer them, be friendly, etc. So we don't have that. I didn't at least see anyone shouting at anyone or something. If you are really busy, you can always tell them to come later. But that's really working very well. I never faced any problem going to anyone asking any question or anyone coming to me asking me question. So we do have that culture. Thinking big is thinking about a bigger scope. I think it explains itself. Not just thinking in the box, thinking outside the box. And you have act as one. So it's important to act as if we were one person. The team always cooperates, working closely together. And that's helping really a lot. And the second point is actually the co-located environment. As I mentioned earlier, we keep moving, sitting close to each other, so we save time if I want to go to and ask my colleague who works in the next team that we somehow, it happened that we will work on similar thing, or I needed some of their knowledge. So this is important. And this is another thing, is we really have low turnover. So few people quit work. Maybe it's a fantastic place to work at. But that's actually a fact. I think we have 5%, and that's really low compared to the Swedish standard where people change companies or change work. So that's important. And the size of development teams is important since it is plus minus 8. So that's manageable, and people can focus on their work. So these are mainly facilitating factors that we found in the study that help drive this process. And this is your question. A quality assurance resource is actually present at each project, at least in our department. So each project we have one person, quality assurance, testing continuously that we are delivering what is specified there. He or she attends the meetings with us, daily meetings, like specification meetings, documentation, etc. And then he knows what's going on. He's aware, and that's important. And then he's testing, and he now, by being there, he will understand what this feature could affect. And then they can decide on what test cases to write and what other features to test. Because that's important. If you develop a feature, it definitely has ripple effect, they call it, like influence on other features, either in performance or creating a new bug that you didn't think of, etc. So that helps a lot. And the orderer as well, the person who says, I want this feature, he works closely with us. And that's, I think, driven from Agile principle, customer on site. So when you have the customer working with you all the time, that helps. They will see the prototype, they can interact with you, you can deliver things better. So these factors, they help actually drive this process. Now, what are the benefits of such process? First one, actually, it is easier to handle and follow. As I said, we have QA with us, we have orderer with us, so we can, if there is an issue, we can discuss it in the same day or in the next day maximum. Here we don't really have to follow rigidly, this process says like this and the process mandates that thing, we should do it in steps. We can do it informally and discuss across the team and amongst people, and it works. The orderer can, as we say, specify still in high orders, like, hey, I want this feature, it's just one line, do it. Then we go through discussions, we discuss with him, with the QA, with other people. We might spend a week actually understanding what he or she wants, but we will get it there at the end. And the orderer has also flexibility in this case, that they can change. It's okay to change your mind, but not at the end, of course. They have some limits. But since they see things, they can see like, oh no, maybe it should be like that. And sometimes we do send things to clients to test it. So we are flexible in that sense. And importantly, we contribute to the culture of the company, the 3 core values. We acting as one, we thinking big, and we are always open. So these are the benefits of not having really a rigid or process to document everything we do or the features. But at the same time, it's not always nice, you know. We have this really big issue. Sometimes it's hard to know what is this feature all about and in which version did we release it. Since we release continuously, sometimes you will have to track things. So traceability could be an issue in this case. So it's not always easy to find a feature, but we don't face this problem, let's say, daily. Maybe each month we will get a request, so you'll spend some time, you will find it out. Also, we have lack of some information, like because requirements are not written, you don't really know how things sometimes work, so you have to go and ask. That could be a challenge. It takes some time. You have also to consider that because that's money and time and budget, and you have deadline. So, but can we live with that? So far, yes. And this is like, what test cases should we test on this software and not on that one? And maybe Baldwin will later talk about how they fix that difficulty. So this is another one. And the last one is, we have actually confusion about the requirements, the quality requirements, and how do we, about their meaning. As I mentioned earlier, an example, we shouldn't degrade, let's say, the frame per second every time we record in the video. But what does that mean? Still, you know, it doesn't mean much. Should I be able to record one recording or 10 recordings when I decide on that? So here it comes some confusion. But how do we deal with that? Again, we go into discussions and we have close relationship and communication, and that works fine. The other question, can we scale? As I said earlier, we're actually growing in number. Each year we, I think, hire about 200 people in different departments. So every day, let's say every month, you get at least 1 or 2 new employees in different departments. And these employees need to work with you, and they need to have this knowledge and information. Is it okay to keep that process or not? As of now, we don't see it as a big issue. Maybe in 2-3 years it will be, but as of now it's okay. So about 1,800 employees working. It's not a problem for us. So as I said, it might become a problem, but that's something we have to reevaluate. And that's we do through this one, continuous evaluation of the process. We have, I think, each 4 or 6 month evaluation of the process as we go. So do we need to change something? What are the current problems we are facing in different aspects? And that's actually working very well, that we are flexible and we can change things. And that's driven completely by the culture. And then we have another question, like, do we really need to have a requirement database? Coming from the school, yes. But working there, it doesn't seem to be necessary. I took an initiative in my department. I do record or write requirements in a high level. So when someone comes to us, we have now description on a high level, like more or less a little bit more detailed than what we get in an order, but at least on how it works, where the problem is, etc. But that's something we work in as a team. So, but as a whole organization, we don't think it's desired. If that is right or not, that we'll know in the future as we grow in number. It could be costly actually to manage requirements because you need to have a system, you need to have people writing them, that takes time, money, etc. Since it is working and as we grow, it is still working, so we still don't think it's necessary. And it requires, of course, large organizational changes. You have to change this in the process, you have to enforce it, you have to do so many things. So, but what you can do, as I said, smaller changes like what I did myself in our team and a few teams followed, that we keep small description of the features somehow, somewhere in our intranet. So that actually helps improve it. So it's about to finish. I think that's the last slide. In conclusion, it's sunny, not outside here. So actually, lightweight process, as we can see, it works for large organizations like the size of Access Communications. And that's actually is helped by the culture we have at work and testing. Testing is important. We have a lot of testing. We have benefits, as I said earlier. We have freedom to choose the process, whatever we like to do, we do that. We are flexible, like we accept changes, we take things, and the lower cost of this process. So it doesn't cost us much to keep information or go through things, etc. The challenges, it's mainly finding information. That could take some time, affecting the cost, but that's something you can still manage. Should we need a requirement database? As of now, not yet, I believe. And but smaller changes, as I said, like recordings, description of requirements, depending on the test cases, that could uh, solve the problem as of now. I think that's it for me. If you have any question, please ask.